Hi you guys, today we're doing 10.1. We're looking at our next unit here. It's a very short unit and it's typically on the easier side for a lot of students, so hopefully it goes well for you. We're looking at matrices in this unit and there's a lot of vocabulary on this page. We're not going to read necessarily every single word on the page, but we'll talk about a lot of these vocab terms. But basically, matrices are just an array of numbers. They're a way to organize numbers so that we can work with them a little bit easier. They're used a lot in like computer programming and coding and things like that. Mathematicians also use them for complicated linear systems. So if you continue down the math route, you might look at matrices a little bit more, but we just do the basics here for now. So let's get into some of the vocab. So again, matrix, it's a rectangular arrangement of numbers in rows and columns. We're going to look at the dimensions today, and it's just how we label the matrix. So you can see an example of dimensions over here. This is a 5 by 2. We'll talk about that more in a moment. Entries are whatever is in the matrix, so the numbers. So like one of the entries in this matrix is 1. Another entry is 9. Right, just whatever's inside. Equal matrices are when they match exactly, so the entries are in the same position and they're the same number. Rows are horizontal and columns are vertical lines of the matrix, and that will help us with our dimensions in a moment here. A square matrix is exactly like it sounds. It would have the same number of rows and columns, so like a 3 by 3 would be a square matrix. And a zero matrix is a matrix with all 0 entries. Okay, that's more useful if you continue learning about matrices and some properties of them. You'll see zero matrix a lot, but we don't go too in depth with it in this class. So let's look at a few examples. They look complicated. It's like, oh my gosh, there's so many numbers. They're really not that bad, especially with what we do with them. So this first example, we're just writing the dimensions. And when we write the dimensions of a matrix, we always write it rows by columns. Some people remember this, that it's in reverse alphabetical order, like it's not alphabetical, so R and then C. To help you remember that you write the rows first. So rows, again, those are horizontal lines of the matrix. So when I count the rows here, I'm looking at how many horizontal lines I see. So I see 1 horizontal line, 2, and then 3. I'm going to write that on the side here. When I look at the columns, I'm looking at how many vertical lines of entries I see. So here's 1, 2, 3, 4. Okay, so when I put that together, that makes this a 3 by 4 matrix. And we write dimensions similar to how you'd write dimensions of like a room. If you're measuring a room, right, 3 by 4, we use that multiplication sign. Okay, let's try 1 or 2 more together here. So again, I'm going to count the rows first. So it looks like I only have 1 horizontal row. 1, 2, 3, 4 vertical columns, even though there's no more underneath them. This would be a 1 by 4. The next one, I'm counting rows first. So I have 3 horizontal rows and only 1 vertical column. So this guy is a 3 by 1. And my last one here, counting rows first. So here's 1, 2, 3, 4 rows and 1, 2, 3 columns. So a 4 by 3. Okay, and those are our dimensions. In the next example, we want to just determine if the matrices are equal. So that means that everything about them needs to be the same. The dimensions, the entries, meaning the like numbers inside, and the position of those entries. So to decide if they're equal, let's just compare entries one at a time. So when I start to do that, 5 appears in like the first spot, the top left, comparing it to that same position, those do not match. So even though the other ones do match, 0, 0, negative, or sorry, oh, and this one doesn't match either. 2 and negative 2 does not match. The last one's negative 5 and 5 do. 2 that don't match, that's where the problem is. So these ones are not equal. They have to be exactly the same. Now when I look at the next one, just glancing at it, I might say, oh, those aren't equal. But if I look a little bit more closely, these entries match. These entries match. Negative 1/2, well, I know that negative 1/2 can be written as a decimal, as negative 0.5. So those actually match. They are equivalent. 3/4 can be written as positive 0.75. So those also match. So these ones are equal. Okay. All right, let's get into some operations with our matrices. So we're just looking at adding or subtracting matrices today. So if we're trying to add or subtract matrices, they must have the same dimensions. Oops. Okay, so they must have exactly the same dimensions. And if you're actually able to add or subtract them, then you would add or subtract the corresponding entries. Okay, so you just kind of match up the numbers in the same position and add or subtract those values. So we'll do a couple together and then you'll do some on your own. So it says perform the indicated operation if possible, because we know that they might not be able to add or subtract if they don't have the same dimensions. So part A, these both look to be a 3 by 1. They're each a 3 by 1, so that's good. So I can add them. So if I'm going to add them, I'm going to draw a new matrix. So just like a little rectangular bracket. I'm going to add the entries that are in the same position. So 3 plus 1. And then underneath that, negative 4 plus 0. And then 7 plus 3. Close my bracket. And then to simplify, I'll actually add those to get 4, negative 4, and 10. So down here is my final answer. Okay. Part B, I'm subtracting this time. So again, just like regular subtraction, order matters. These are both a 2 by 2, so that's good. And so I'll subtract entries in the same position. Okay, so in the top left, I'm going to do 8 minus 2. Top right, I'll do 3 minus negative 7, right? Minus a negative. Bottom left, 4 minus 6. And then 0 minus negative 1. Notice I'm leaving some space right in between my entries to kind of keep track of everything. I'll simplify that matrix. So 8 minus 2, 6. 3 minus negative 7, that becomes addition. So it would be 3 plus 7, which would give me 10. 4 minus 6 is negative 2. 0 minus a negative 1 becomes addition, so that would be positive 1, 0 plus 1. And then lastly here I have part C. When I look at these two, they don't seem to match. This guy is a 2 by 2, and this one has 2 rows and 1 column. So if I wanted to add them, I don't have corresponding entries. Like for this column here, I don't have anything that matches it. So that means it is not possible to add these matrices. I'm going to switch to typing. So it's not possible because the dimensions don't match. Okay. So at the bottom here, you have 3 problems I want you to try on your own. And then I'll go through the explanation in a moment. Okay, so here are my final answers for these 3 problems. So I tried to highlight kind of where those corresponding entries are just based on the columns. So at least if you're having a little trouble like following, that might help a bit. And I am writing out all my work here, especially as you get started. I would suggest you write out your work so that you don't lose track of where you are, which positions you're looking at. So then my final matrix answer is right here in the black rectangle. Okay, so one thing to keep track of, like whatever dimensions you start with should be the same dimensions that you end with. So for part A, these are both a 3 by 2. So our final answer is a 3 by 2. Okay, and feel free to pause so you can look more closely. Part B was not possible because the dimensions do not match. And then my answer for part C is here as well. And again, I highlighted just the columns so you could kind of see how I'm matching up the entries. And for part C, you were subtracting, so make sure you kept track of those negatives as well. Subtracting a negative becomes addition.